All right, so my name is Bill Porter, for people that don't know. I'm one of Felix's technical staff for this event. I'm in charge of the networking around the pool, around the pond, excuse me, configuring the routers and things like that, so I know a thing or two about networking. And I wanted to talk to you today about something that teams struggle with, which is how do they connect their boats to Felix's network in order to report to the server. We've seen a couple different approaches. I've seen a couple different teams that weren't quite sure how to configure it or what they were configuring. So I'm going to bring you through a little bit of the basics of that to help you solve that part of the problem a little bit easier. And what I mean is, who knows this box? The box in Windows that shows you the details of all your IP settings and things like that. Yeah, usually you go in here when something's not working and you're trying to figure out why, right? Do you know what each one of these numbers means and what it does? Not really? Well, my part of the lesson is going to be to tell you what each one of these numbers means to help you troubleshoot problems or help you configure your network a little bit better. So let's start with the basics. Networking is the connection of computers together in order to share information between them. For example, your boat sharing information with Felix's server. And we're only going to talk about IPv4, which is the version 4 of IP protocol, which is what goes over a network. You may have heard that there's v6 out there, but we're not going to mess with that here. It's really complicated. Not many people use it. We're still on v4 more or less for the most of the world, including here. So what do these numbers mean? Like I said, that's what we're going to talk about. All these numbers in this dialog box right here. And I'm going to teach you today what those mean and what they do to help you make sure they're configured correctly. When you look at IPv4 address, there's actually two parts to it. The first part's the network, and the second part is the host. Normally, in most cases, the first three numbers is the network. The last number is the host. So when you see 192.168.100, that's the address of the network, and that last number is the address of your host. You put that together, your computer puts that together to make a routing map to figure out how to route data. Tried swiping the TV, that didn't work. So if we think of a network, it's kind of like a close group of friends. The friends will all share that first three numbers, because that identifies the group of friends, and then each friend will have a different last number or a different host number. That's the basic computer network right there. They'll all share the first three sets of numbers, and that last number is what each individual member of that network has that's unique to them. That can change. That's where the subnet comes in. Subnet lets you change what part of that number is the network and what part of that number is the hosts. The trade-off is you can change the number of possible hosts in your network, but then you have less network numbers to have less networks. So you trade networks for hosts, basically. And that's where the subnet mask comes in. The subnet mask basically says these numbers are set for network, this last one's set for host, or if you see like that, that means only the first two numbers are set for network and the last two numbers are set for host. There is actually numbers in between that. You can see it where it has, instead of just 0 or 255, it could be like 192 or some other number, because you can actually get even finer detail about what numbers you consider for the network and what numbers you consider for hosts. So that's what subnet mask does. Just tells the computer which part of the address is the network and which part of the address is the host. So we've nailed two of these so far. We know what the address is. That's the address of the computer. And we know what subnet mask is. That tells the computer which part of the address is for network and which part of the address is for host.
So for that example, was it just saying that only the last number is? So it says 25. Oh, got it.
So when you see this, that means this part is network, that part's the host. And since you can only go to 255 here, you can only have 254 possible hosts with that configuration. Okay. You can't build a network of more computers than that in that configuration. If you guys ever look at your cell phones right now, if you're on our student Wi-Fi, you'll notice our student Wi-Fi is actually 172.0.12 or 3 because we expanded the network in that one. Because we figured there may be a chance that there's more than 254 cell phones that are attaching to student Wi-Fi. So that network we built to be one that's closer to this kind of setup where we can have more hosts just in case we need to. The only reason we're talking about this is so you guys know what this means when you look at your IP settings. That's more or less what that means.
Is a host, is anything connected to the network?
A host is correct, a device, a computer, a PDA. That's the host part of the address says this is that unique device in your network. So we got both of these parts of the, now we know what these two numbers mean, your address and your subnet. Let's talk about going wider. We have some terminology we need to know. The difference between LAN and WAN. LAN means local area network. That's what we use to define our close group of friends that all have the same network but different host numbers. WAN means other networks, wide area networks, out to the internet, out to expanded reach kind of thing. So to understand LAN versus WAN, let's relate it to a party. Your close group of friends is your LAN. That's your small little network. Other party guests, the bigger party would be your WAN. All the people you don't really know. So when you're in your LAN, you know how to talk to all your friends that are part of your network. But you can't talk to anyone else in the party because you don't know them. We're just going to pretend we're all introverts, right? So we're not going to talk to the other guests in our party because we don't know them. This is someone else's party. One of our friends is the friend that brought us to this party. And we can talk to them because they're part of our network, but we can't talk to anybody else. So how do we solve that? The concept of a gateway. We're going to talk about Gabby Gateway. Gabby Gateway, she's the person that brought your friends to this party. She knows the party hosts and the other guests. She has knowledge of the WAN, the bigger group of networks out there. So if we want to talk to one of them, we actually go through her first. We go through Gabby Gateway. So by knowing which one of our friends is the gateway, we know how to get to anywhere else, to get to somebody else in a bigger network. So that really is what this means. So now we're under our third number, default gateway. That's the purpose of the default gateway. The default gateway is the device in your network that knows more about the rest of the networks in the world. This device at home is typically your router. You may know when you buy a Linksys router and plug it in that if you do DHCP, you'll notice that the IP address that is listed as the default gateway is the IP address of your router. And that's because your router is the gateway. It's the device in your network that knows more about other networks, or the internet at large mostly. So now we've gotten through the first three numbers now. We know what gateway means. Any questions on gateway?
So can a host be a gateway?
Yes. Your host, so notice in this example, my network is 192.168.100. My particular computer is .50. Notice my gateway address is 192.168.100.1. So he's part of my network, and his address is 1. He's a host at 1, and he's my gateway. He's the device that my computer talks to in order to talk to other computers out on the internet.
But if you wanted to, we can change the default gateway to make it 192.168.100.50.
If that is the device that is a gateway, it has to be a device that knows about the internet. Okay. So it typically is your router. You can make your computer a router, but then your computer needs to have two network interfaces. One for your network and one out to the internet.
Okay.
Any questions on gateway? So when a connection is requested for a destination address that is not in your local area network. So if your computer says, go out to an address that's not my local network, it doesn't try to go to that address directly. It actually sends that request to your gateway. And the gateway will forward the request to the device on the WAN network, or the internet at large. All right, last number, DNS. This one's super easy. All the DNS does is take what we know as humans and translates it to computer numbers. So when we type in google.com, the DNS is the device that comes back and goes, okay, the IP address of google.com is this. And that, last time I looked it up, when I wrote the slides a couple weeks ago, that was the current IP address of google.com. So it's hard for us to remember that, right? I'm never going to remember that. You can remember that? So the whole point of DNS is just to translate what we can remember, google.com, to what the computer needs to know to route the data, which is the longer IP address. So that's the last number there. So now we've covered all 4 sets of these numbers that are required to understand a network or how to fix network problems. Any questions on any of that? Are we all networking experts now? So let's talk about how that actually affects what we're doing here. So I'm going to suggest this approach when setting up your network for your boat and having to talk to Felix's servers. A couple teams do this. So if you don't do this yet, you can talk to a couple other teams if you need more help. And that's to use a router. You have that router next to your OCU at the table. With that router, you plug the TD network into the internet port, the WAN port. And then you can plug your operator station directly into one of the LAN ports. What that does is that allows your boat, which will be on that same LAN, to use the router as a gateway to talk to Felix's server. So when you type in the server address, which is 192.168.65.2 or 66.2 or 67.2, since that address won't exist on your LAN, your boat, the computer on your boat will use the router as a gateway to then get out to that network to talk to Felix's server. The teams that do this have the most success in my experience in their setup and how they run their boat communications and how they run talking to Felix's server. There are other ways to do it. You don't have to do it this way. This is just one of the easier ways to understand and easier ways that, and more successful ways that I've seen with the teams. So if you think about it, your boat and your OCU are on the LAN. That's your close-knit party of hosts that all know each other. And then the TD network is on your WAN. And the router is on both because the router is the gateway. So it's a host on your LAN, plus it's a device on the WAN of the TD network. And it acts as the gateway to route the traffic. And I think that's all for networking. Any other networking questions?
So the other devices in the WAN, can they access devices other than the gateway device on the local network?
No, unless you put rules in your gateway to be able to deal with the traffic. Because when your gateway only exists as one host on the WAN. It masquerades or hides all the other hosts on the local LAN. So if you ever had problems with Xbox and it said like go into your router and add port forwards, that's what that does. A port forward says if something tries to come from WAN to LAN on this port, redirect it to this local host. That's what the purpose of that is.